Hey everyone, and welcome! Today, we're going to totally change how you think about the periodic table. Seriously, forget that dusty old chart from your science classroom. We're about to see it for what it really is, an incredible, powerful cheat sheet for the entire universe. Let's dive in and start decoding it. And this quote from the chemist Glenn T. Seaborg just nails it. He says the periodic table is probably the most important idea in all of chemistry. Why? Because it proves that all the stuff that makes up our universe, it's not just a random jumble. There's an order, a beautiful hidden pattern. And once you see that pattern, well, you can start predicting how everything works. So that brings us to the big question, doesn't it? How on earth did scientists take this chaotic mess of different elements and turn it into such an elegant, organized map? It's an awesome story of puzzle solving, incredible insight, and yeah, a little bit of pure genius. So here's our plan. First, we'll look at the early hunt for a pattern. Then we'll get to Mendeleev's masterpiece. We'll see how a major upgrade created the modern table we use today, and then we'll decode its secrets, unlock its superpowers, and talk about why it's so important. Okay, so our story begins with a huge challenge. As scientists kept discovering new elements, they were basically building up this collection of materials, and each one had its own unique personality. They just knew there had to be a pattern hiding in there somewhere, but finding it, that was the really hard part. To give you some perspective, let's go back to the year 1800. At that time, the scientific world only knew about 31 elements. Okay, that's a number you could maybe wrap your head around, right? It seems kind of manageable. But things were about to get a lot more complicated. Because get this, by 1865, the number of known elements had more than doubled to 63. All of a sudden, this wasn't a casual problem anymore. It was urgent. The chaos was just getting out of hand, and chemists were desperate for some kind of system to organize it all. So one of the first big clues came from a German chemist, Johann Dauber-Reiner, and his triads. He noticed that some elements could be grouped into threes. Look at this first triad here. The atomic weight of sodium, which is 23, is almost the exact average of lithium 7 and potassium 39. That's not just a coincidence. It was the first real hint that there was a mathematical order. The only issue was it only worked for a handful of element families. All right, next attempt. In 1865, John Newlands came up with the law of octaves. He had this beautiful idea, linking chemistry to music. He arranged the elements by weight and saw that their properties seemed to repeat every eighth element, just like notes in a musical scale. You can see how sodium here, the eighth element after lithium, acts in a similar way. But the music kind of stopped working after calcium. His law just broke down for the heavier elements. So, another piece of the puzzle, but still not the whole picture. And that brings us to our hero, the Russian chemist Dmitry Mendeleev. You see, while other people had spotted bits and pieces of the pattern, Mendeleev was the one who saw the grand design and created the first truly powerful, predictive periodic table. This right here was his core idea. He took the 63 elements they knew about and started arranging them by increasing atomic weight. And as he did this, he wasn't just looking at the weight. He was focusing on how their chemical properties repeated in this predictable, periodic way. And this is the most important part. Mendeleev's real genius wasn't just about organizing the known elements. It was his incredible, bold confidence in what was not yet known. When an element didn't seem to fit his pattern, he didn't try to force it. Instead, he had the guts to leave a blank space, predicting that a totally new element would one day be discovered to fill that exact spot. I mean, just look at this as proof. He predicted an element he called eka-silicon, which would sit right below silicon on his chart. He even described what it would be like in amazing detail. And what happened? 15 years later, an element called germanium was discovered, and its properties were an almost perfect match. This was the moment his table went from being just a clever chart to a proven, powerful scientific tool. Now, Mendeleev's table was revolutionary, but it wasn't quite perfect. There were still a couple of little things that didn't quite line up. The fix came from a massive upgrade to its core organizing principle. And that's what created the ultimate cheat sheet we use today. So here it is, the single most important change that perfected the entire table. You see, Mendeleev sorted his elements by atomic weight, basically how heavy they are. The modern table, though, is organized by atomic number. That's the number of protons in an atom's core, and it's what truly defines an element. This one simple switch fixed all the remaining problems and locked the table's order in place for good. And there it is, in all its glory, the modern periodic table. The rows going across are called periods, and as you move across a period, you're adding one proton at a time. The columns going down are called groups or families. And this is the magic part. Elements in the same group share really similar chemical properties. Okay, so why does the table have this particular shape? With those different size blocks? Well, it's not random at all. The table structure is basically a map of how electrons arrange themselves around an atom's nucleus. It's all about the electrons. Now, this statement sounds super technical, but it gets right to the point. The layout of the periodic table isn't just chemistry. It's actually a visual map of quantum physics. An element's address on the table tells you exactly how its electrons are set up. Think of it like a blueprint for an atom's electron housing arrangement. So the table is broken down into these four main neighborhoods. That tall part on the left, that's the S block. The wider section on the right is the P block. The valley in the middle is the D block, full of transition metals. And those two rows that seem to float at the bottom, that's the F block. An element's block is just decided by which type of electron house, or orbital, is being filled. This structure is the real reason for those repeating patterns that Mendeleev first noticed. All right, now for the super fun part. We've seen how the table is built, but its real magic, its superpower, is how you can predict what an element will be like and how it'll behave just by knowing where it lives on the chart. These are just a few of the big trends you can see just by looking at the table. By knowing an element's position, you can make a really good guess about how big its atoms are, how easily it gives up an electron, and whether it's going to be a shiny metal or not. For a chemist, this is an unbelievably powerful tool. Okay, let's put that to the test. Here's a little challenge for you. Based on what we've talked about, how would you arrange these 5 elements, from the least metallic to the most metallic? Here's a hint. Metallic character tends to increase as you go down a group and decrease as you go from left to right across a period. Take a second and think about it. And there's our answer. The correct order is phosphorus, then silicon, beryllium, magnesium, and finally sodium. Sodium, or Na, is the most metallic because it's way over on the left in group 1. And phosphorus, P, is the least metallic because it's the furthest to the right out of this bunch. See? The table just gives you the answer. So we've gone through the whole story, the history, the structure, the amazing predictive powers. Let's just pull it all together and really hammer home why this isn't just some icon of science, but an essential, everyday tool. This is the #1 thing to remember. The periodic table isn't just a list, it's a predictive engine. It's this beautiful, logical system that summarizes the fundamental laws of physics that govern all matter. It lets us understand everything we found and even predict the nature of things we haven't discovered yet. And that leaves us with one last really cool thought for the future. Scientists in labs are always pushing the limits, creating new, super heavy elements that don't exist in nature. So the question is, will our perfect little map of the universe need an extension? Could we be adding an 8th row sometime soon, literally expanding our map of reality? It just goes to show you the incredible, lasting power of this scientific masterpiece.